LeChatelier's principle states when a system is in equilibrium, there's a delicate balance between the reactants and the products. LeChatelier's principle refers to any kinds of disturbances to this system as stresses. When a stress is applied to a system, the balance is interrupted. If a system at equilibrium undergoes a change, the system will shift to release that stress. So our three types of stress are change in concentration, change in temperature, and change in pressure. The easiest one is probably concentration. If you add a reactant, it shifts towards the product. You add a product, shifts towards the reactants. You remove a reactant, and it'll shift towards the reactants to fill that hole. You remove a product, it'll shift towards the products to fill that void. When concentration changes, the equilibrium ratio remains the same, therefore K remains the same. Temperature is the only thing that changes K. So if you increase the temperature, let's remind ourselves first, K is products over reactants. If you change the temperature, you have to know if the reaction is endothermic or exothermic. If a reaction is exothermic, then that means energy is like one of the products. If the reaction is endothermic, then energy is like one of the reactants. So increasing the temperature causes the equilibrium position of the reaction to shift in a direction that absorbs heat. So exothermic reactions, heat is one of the products. Adding heat pulls the reaction to the left. It'll shift it towards the reactants. Removing heat in an exothermic reaction is like removing a product. So it'll shift towards the products and the concentration of products increases. So K is the one that does change with temperature. So in an exothermic reaction, you increase the temperature, it shifts towards the reactants and makes the concentration of the reactants greater. That makes K decrease. If you shift towards the products in a reaction, then the concentration of the products will increase. If the concentration of the products increases, then K increases. So you can kind of remember that. If the concentration of the products increases, K increases. If the concentration of the reactants increases, K decreases. This is only for change in temperature. K stays the same in all other types of changes. A change in pressure is only going to affect the equilibrium position has unequal number of moles of gaseous reactants and products. So let's clarify that. It only has to do with gases pressure. So you ignore solids, liquids, and aqueuses when it comes to pressure. It only affects it if you have a different number of moles of gas on the reactant side as you do on the product side. If you have the same number of moles of gas on both sides, it will not change. So an increase in pressure always shifts the chemical reaction towards the side that has the smaller number of moles of gas, the side which will cause it to decrease in volume. A decrease in pressure favors the side that has the highest number of gaseous particles. So if you decrease the pressure, think of being able to spread out to the side with more moles of gas. This is a summary of the effects of different changes or stresses. Let's put this into practice. Our first reaction is phosphorus pentachloride absorbs heat as it turns to phosphorus trichloride and chlorine gas. Our first type of stress is to add a product. So if I add a product, the concentration of Cl2 is going to increase momentarily, and then the equilibrium position will shift towards the left to try to compensate for that extra chlorine or consume that extra chlorine. So as it shifts towards the left, the concentration of PCl3 will decrease and the concentration of PCl5 will increase. If I add PCl3, the same thing happens, shifts towards reactants. Here's this pressure one. This can be a little bit confusing. So we're going to go and we're going to count, and we're going to remember that if there's nothing written in front of here, it's 1. So we have 1 mole of PCl5 on the reactant side. We have 1 mole of PCl3 and 1 mole of Cl2 on the product side. So it's 2 moles of gas on the product side. So if I decrease the pressure, the gas is going to want to spread out and it'll shift to the side that has more moles of gas. If I increase the pressure, it's going to shift towards the reactants. Now this is the trickiest one where it's going to affect K. So if I remove heat, it's like removing a reactant and it'll shift towards the reactants. That means the concentration of reactants will be greater. Remember, it's products over reactants, so that means that K will decrease if we remove heat. If we add heat, that's like adding a reactant, so it'll shift towards the products to counteract that stress. As it shifts towards the products, the concentration of the products increases, the concentration of the reactants decreases, therefore the numerator increases and K increases. If I remove a product, it'll shift towards the products to fill that up. If I remove a reactant, it'll shift towards the reactants to fill that void. The only stresses that change K are E and F, that change in temperature stress. Okay, let's look at this next one. This one's a little bit different. This is called a heterogeneous reaction, meaning that carbon is a solid, H2O is a gas, CO is a gas, and H2 is a gas. So heterogeneous means we have different states of matter. Remember, when it comes to K, we're going to ignore the solids and liquids. So the K for this becomes concentration of the products over the concentration of the reactants, only the ones that are gaseous. So when you count the number of moles of gas, it's 1 on the reactants and it's 2 on the products. See how I simply ignore that solid. So if I lower the temperature, it's like removing a reactant, it'll shift towards the reactants. Increase the temperature, it'll shift towards the products. Remember, when you shift towards the reactants or shift left, the denominator of K gets bigger, so K will decrease. Lowering the pressure, spread out, increasing the pressure, compress. Remove a product, shift to compensate that by shifting towards the products. Remove a reactant, shift this way. And the only stresses that change K are the ones that have to do with temperature. Here's an exothermic one. We'll go through this a little bit more quickly. Exothermic means that heat is released. This particular case, we have 9 moles of gas on the reactant side and 10 moles of gas on the product side. When I lower the temperature, it's like removing a product. It'll shift towards the products to compensate that. When I increase the temperature, it's like adding a product. It'll shift to the left. So let's figure out what happens to K. If I shift towards the products, And K is products over reactants. That means the numerator gets bigger. That means that K gets bigger. Lowering the pressure, I'm going to spread out to the more moles of gas. Increasing the pressure, I'm going to compress them. I remove O2. It's removing a reactant. It'll shift left. Only the stresses that change temperature are going to change the K value. These two are solids, so they get left out. That means that my only moles of gas are 3 on the reactants, 3 on the products. This is listed as a delta H of plus 15. That means the plus means that it is a reactant. It's entering the system. Heat is entering the system. Therefore, it's endothermic. So if I lower the temperature, it'll shift towards the reactants. If I lower the temperature and it shifts towards the reactants, K is going to decrease. This time, when we say lower the pressure and increase the pressure, you're going to say no change. Nothing's going to drive it one way or the other because we have the same number of moles of gas. Therefore, they want the same volume on both sides. Removing a reactant will shift towards the reactants. Removing a product will shift towards the products. So that is an overall summary of LeChatelier's principle.